Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So if you want to learn physics, chemistry and mathematics starting from 8th standard till 12th standard, so you can please do subscribe to my channel. In this particular video, I will be teaching the 11th chapter of 8th standard mathematics subject. So the 11th chapter in 8th standard mathematics subject is direct and inverse proportions. So in this particular part, I will be teaching direct proportions. So there will be second part for this particular chapter which I will be uploading. So that will be on inverse proportions. So when you go through both the parts of this particular chapter, you will understand both direct and inverse proportions, which is the 11th chapter in this 8th standard mathematics subject. So coming to the direct proportions in this particular video, what do you mean by direct proportions? So let me take an example and then make you understand what is direct proportions. Let's suppose say there are two physical quantities. So what do you mean by a physical quantity? So physical quantities, as the name itself suggests, whichever you can experience. So those kind of quantities are known as physical quantities. Just like heat. Heat is one of the physical quantity. Mass is one of the physical quantity. Even your height or the length or the distance, that is also a physical quantity which you can measure, which you can actually clearly experience. So such kind of quantities are known as physical quantities. So now if I actually compare two different physical quantities, so if one particular physical quantity is changing directly or changing as the second particular physical quantity is changing. So for example, if this particular physical quantity is increasing, then this particular physical quantity will also increase in the same rate. So that is what directly proportional means. So when it comes to inverse, when one physical quantity increases, the other physical quantity will decrease. So the increase or decrease in one physical quantity is decided by the other physical quantity based on whether they are directly related to each other or inversely related to each other. So let's say I'll take one example. When you go to a shop, there you will buy some sugar. So let's say the rate of sugar is 40 rupees. So 1 kg of sugar cost 40 rupees. So let us imagine this. So this is actually the mass of sugar. So I'll write mass, and here I'll write cost of the sugar. Instead of writing mass, I'll write weight, because basically you will be calculating weight of sugar. So 1 kg of sugar cost 40 rupees. So similarly 2 kg of sugar cost 80 rupees. Similarly 3 kg of sugar cost 120 rupees. 4 kg of sugar cost 160 rupees. So let us assume this particular case. Here you can clearly see weight is one particular physical quantity. So I have mentioned here the relation between two physical quantities should be directly related to each other. Now here the two physical quantities which I have taken as example are weight and cost. Weight of the sugar and cost of the sugar are the two particular physical quantities which I have chosen. And here you can clearly see, as one physical quantity is going on increasing, the other physical quantity is also going on increasing respectively. So here one thing you should notice, here the increase you can clearly see when there is 1 kg of difference, then there is 40 rupees difference is there. So let's say there is 2 kg and 3 kg. So from 2 kg to 3 kg there is 1 kg difference. And from 80 rupees to 120 rupees there is 40 rupees difference. Means the weight of sugar is increasing at the rate of 1 kg and the cost of sugar is also increasing at the rate of 40 rupees. That means constantly it is going on increasing. So that particular constant increase is actually known as constant, which is linking the equality of two physical quantities. So let me explain that. Here let us take weight as x. So let us take weight as x and let us take cost as y. So here x is actually increasing and y is also actually increasing. So when x increases, y also increases. So now when there is increase, like when there is direct relation between two physical quantities, that means if one increases, one other physical quantity is increasing, and if one physical quantity decreases, then other physical quantity which is related with that particular physical quantity will also decrease. So in this particular case, we will actually write a symbol like this, which will actually tell us that this particular x and y are directly proportional. Now I have to make this particular x and y equal to each other. So at that particular time, you should see at what interval the increase is happening. So here y is increasing at the interval of 40 rupees and x is actually increasing at the interval of 1 kg. So here, to make this equal, we have to bring a constant called k. This constant actually represents at what particular rate this particular increase is happening in two physical quantities. So now if I bring this particular y to LHS, then it will become x by y is equal to k. That means the ratio of x and y is decided by the rate of increase of those two x and y. So now here you can clearly see the difference between two is similar across the values which we have taken here. So the difference between 1 kg and 2 kg is 1. Difference between 2 kg and 3 kg is also 1. Difference between 3 and 4 is 1. Here also in y, difference between 40 and 80 is 40. Here also difference between 80 and 120 is 40. Here also difference between 120 and 160 is 40. So here you can see there is constant increase as there is constant increase in x values. So this is actually known as proportionality constant. So this particular proportionality constant will relate two different physical quantities in an equation like this, x is equal to ky. This particular proportionality constant will vary based on what kind of physical quantities you are actually comparing together. So here this particular k is actually the proportionality constant. So I'll just write that proportionality constant. So this particular constant tells you how these two physical quantities are equated with each other, how they are actually varying with each other. So that is what this particular proportionality constant decides, and hence finding this proportionality constant will also become an important thing in calculating certain relation between two physical quantities. Now we know that here x1 is actually 1 kg. For example, you can clearly see 1 kg, 2 kg, 3 kg, 4 kg are all x values. So now 1 kg will become x1, 2 kg will become x2, 3 kg will become x3, 4 kg will become x4. Similarly, 40 will be y1, 80 will be y2, 120 will be y3, like that. So here you can clearly see x1 is equal to 1 kg, x2 is equal to 2 kg, y2 is equal to 80 rupees. Similarly, x3 is equal to 3 kg or y3 is equal to 120 rupees. So now we know that x divided by y is equal to a constant. So let us see what is the constant which is there in this particular problem. So here in the place of x and y, we will go on substituting values like x1 divided by y1, x2 divided by y2, x3 divided by y3. We will go on testing whether they will get same constant values or not. So what is x1 by y1? x1 divided by y1 will be equal to 1 divided by 40. So what is x2 divided by y2? x2 divided by y2 is 2 divided by 80. Here you can see 2 ones are 2 4s are 8. So 0 is there. So it will become 40. So 1 divided by 40. And x3 divided by y3 is equal to 3 divided by 120. Here also you can see 3 ones are 3 4s are 12. So this also will become 140. That means this particular proportionality constant k in this particular case is equal to 140. So here proportionality constant k will be equal to 1 divided by 40. So x1 divided by y1, x2 divided by y2, x3 divided by y3, any x values, any y values, when you are going on taking corresponding ratios of both x and y values, you are getting same proportionality constant. So that's why it is known as constant, which is not changing. Even when you substitute x1, y1, even when you substitute x2 and y2, even when you substitute x3 and y3, whenever you are actually going on taking ratios of different x and y values, constant, the 1 by 40 value is not changing. So that's why that particular number is known as constant, which is linking the x and y values. So that's why it is known as proportionality constant. We can clearly see that x1 by y1, yes, is equal to x2 by y2, because when you did x1 by y1, you got 1 by 40. When you did x2 by y2, that time also you got 1 by 40. When you did x3 by y3, at that time also you are getting 1 by 40. All these three are equal to the proportionality constant k. So whenever they have asked certain problems in your examples or in your exercise, means you should find out the values of x1, x2, y1, y2. For let's say they will give some proportionality constant value and they will tell to calculate y1 and they will give some x1 values, or they may give x1, y1 and y2 values. They may tell to calculate x2 values when they are directly proportional to each other. So always you should remember, when there is direct proportionality, when directly proportional, when two physical quantities are directly proportional, at that particular time the main equation which you should remember is x is actually equal to ky, which is actually in turn will be x divided by y is equal to k. So here x1 y1 will be equal to x2 y2 will be equal to x3 y3, and it goes on like this. So this is actually the direct proportionality. So here x and y are varying accordingly. So when x is increasing, y is also increasing. When x is decreasing, y is also decreasing, and there is a proportionality constant which is linking these two physical quantities. So this is all about direct proportions. So based on this particular concept, direct proportions, you have certain examples discussed in this particular chapter. You can go through that examples and understand how they have solved that particular examples. Now I'll straight away move to the exercise problems and I'll go on solving exercise problems. You'll get an idea how to solve a particular problem, how to approach a problem where you can calculate different physical quantities when direct proportionality is there between two physical quantities. So let us solve the exercise problem so that we can more understand this particular direct proportions. So coming to the exercise 11.1. So in the first question, they have actually given parking fees for different time period. So let me take time as one particular physical quantity, and there is some parking fees. So there is parking fees which is there for a particular time period. So if you are parking a vehicle for 4 hours, then the parking fees will be 60 rupees. If you are actually parking this particular vehicle for let's say 8 hours, at that time the parking fees will be 100 rupees. When you are actually parking this particular vehicle for 12 hours, then parking fees is 140 rupees. So when you are parking vehicle for 24 hours, then parking fees will be 180 rupees. So here this particular time will act as x values, and this particular 60, 100, 140, 80 will act as y values. So here you can clearly see as the time increases, even parking fees is increasing. Let us check whether this is directly proportional or not. So whenever there is direct proportionality coming into picture, so at that particular time when you take ratio of corresponding x and y values, that should always be equal to one particular number or one particular value. That is actually the proportionality constant. So here let us check all these x1, y1, x2, y2, x3, y3 are equal to each other or not, equal to one particular value or not. So that is for a proportionality constant or not. So here x1 is actually 4 by 4 and y1 is actually 60. 4 ones are 4, 4 ones are 4, 2 is there, so 20, 4 5s are 20. So 1 by 15 is the x1 by y1 value. So now let us calculate x2 by y2. So x2 by y2 is 8 by 100. So 8 by 100 is actually 2 by 25. So here you can clearly see x1 by y1 is equal to 1 by 15. x2 by y2 is equal to 2 by 25. Now even let us solve x3 by y3. What is x3? x3 is actually 12 divided by y3 is 140. So here 2 6 are 12, 2 7s are 14, 0, 2 3s are 6, 2 35. So 3 divided by 35. So here you can clearly see x3 by y3 you are getting 3 by 35, x2 by y2 you are getting 2 by 25, x1 by y1 you are getting 1 by 15. Means here all x1, y1, x2, y2, x3, y3 are not getting equal to each other. That means they are not getting equal to one particular value. They are getting different values. So in x1 by, when you do x1 by y1 you are getting 1 by 15. When you do x2 by y2 you got 2 by 25. When you did x3 by y3 you are getting 3 by 35. So you are getting different values. You are not getting a constant values. So that's why this is not directly proportional. So the answer for this first question is no. So this is not directly proportional. In this particular question they have asked to check whether this particular problem is directly proportional, like these two physical quantities, time and parking fees, are directly proportional or not. Here it is not directly proportional because they are not getting equal to a particular constant value. You are getting different values when you actually take ratios of different x and y values. So the answer is no for this first question. So coming to the second question, here they have given the case of direct proportionality. So here they are actually mixing one part of red pigment for 8 parts of base for a paint. So now you should calculate for different parts of red pigments how much base is actually required. So here x values are parts of red pigment. So the x values are parts of red pigment. I'll just write RP, and y values are base. How many parts of base? So parts of base. So for one particular red pigment, 8 parts of base should be mixed. So how much you should actually mix for 4, how much you should mix for 7, how much you should mix for 12, and how much you should mix for 20. So here you should go on filling this particular y values. So in this particular case, how much parts of base you are taking, that much amount of red pigments will go on increasing. These two physical quantities are constantly dependent on each other. So they are directly dependent on each other. So that's why here 1 by 8, 4 by y2 value, 7 by y3 value will be equal to each other. So here let's go on calculating the values for y. So here let us take this particular 1 as x1, this particular 4 as x2, this 7 as x3, this particular 12 as x4, 20 as x5. Here 8 will be y1, this will be y2, this will be y3, this will be y4, this will be y5. And this particular two physical quantities are directly proportional to each other. So here you should go on calculating y2, y3, y4, y5. When two physical quantities are directly proportional, then x1 by y1 will be equal to x2 by y2. So what is x1 here? x1 is 1, and y1 is 8. What is x2 here? x2 is actually 4, y1 is actually, sorry, here y2 should be there. So x1 by y1 is equal to x2 by y2. So y2 is, we don't know what is y2. So let us cross multiply this. So y2 into 1 is equal to 4 into 8. So what is the equation we are getting? y2 into 1 is equal to 4 into 8. So y2 will be equal to 8 4s are 32. Similarly, now you can compare this x1 y1 with x3 y3, because whenever you take ratios of x and y, they will be equal to each other because they are all equal to one particular constant. So x1 by y1 will be equal to one constant, x3 by y3 will also be equal to one constant. So there will be one particular value which all this x1 y1, x2 y2, x3 y3 will be equal to. So that is proportionality constant. So that's why based on that I have already taught you that x1 by y1 is equal to x2 by y2 is equal to x3 by y3. So similarly here also I am taking x1 by y1 is equal to x3 by y3. So what is x1? x1 is 1, y1 is 8, x3 is actually equal to, here you can see 7. So 7 by y3. Now we don't know what is y3. We should calculate y3. Again you can do cross multiplication. It will become y3 into 1 is equal to 8 into 7. So y3 will be equal to 8 7s are 56. So y3 is actually equal to 56. Similarly you can find out y4 and y5. by making x1 by y1 equal to x4 by y4 is equal to x5 by y5. So like that you can compare with each other and you can actually get the values for y4 and y5 as well. Coming to the third question in this particular exercise, here also they have given red pigment and base. So here they have given values. So here for one red pigment, so one part of red pigment is there, then they are mixing this particular one part of red pigment in 75 ml of base. So here one pigment is getting mixed with 75 ml. So how many red pigments is required for 1800 ml of base? Here these two physical quantities are directly related to each other. So here one particular physical quantity is red pigment, that is x1, and this particular x2 we have to calculate, and y value is y. So this particular base acts as y values. So here another physical quantity is base, that is actually y1 and y2. So here y1 is 75 ml, y2 is 1800 ml. We know that x1 by x2 is equal to y1 by y2. So here we can take cross multiplication. Before that we can substitute values for x1 and y1. So x1 is one red pigment, so 1 is the value for x1. We don't know what is x2, is equal to what is y1. Y1 is 75 ml. What is y2? Y2 is 1800 ml. So here you can see ml gets cancelled. You can take cross multiplication of this. So this will be equal to 1 into 1800 is equal to 75 into x2. So this particular 75 when you bring to LHS, it will be equal to 1 into 1800 divided by 75 is equal to x2. So the value which we are getting is x2 is equal to 1 into 1800 divided by 75. So here this particular equation you can actually solve. 5 ones are 5, 2 will be remaining, 25, 5 5s are 25. Here 5 3s are 15. So 3 will be remaining, 30, 5 6 are 30, 0. So here 5 3s are 15, 5 7s are 35, 1 is remaining, 5 2s are 70. So 5 2s are 10. So 3 1s are 3, 3 2s are 6, 12 will be remaining, 3 4s are 12. So the x2 value is 24 red pigments. So for one particular red pigment, basically you are doing cross multiplication of two physical quantities because they are directly related to each other. So here x1 is one red pigment, 75 ml base is required. So now 1800 ml base is there. So that many red pigments you require. So for that you have done cross multiplication, or according to the law of direct proportion, x1 by y1 is equal to x2 by y2. When you substitute x1 y1 value, x2 y2 value, you got the answer for x2. You might be wondering why I have taken x1 by x2 is equal to y1 by y2. That also I will explain. Here we know that x1 by y1 is actually equal to x2 by y2. So when you bring this particular x2 to LHS, that will go to denominator. So it will become x1 by x2. So when you bring this particular y1 to RHS, then this y1 will go to the numerator. So this will be equal to y1 by y2. So either you can write x1 by y1 is equal to x2 by y2, or you can write x1 by x2 is equal to y1 by y2. This will be helpful for you to solve problem in a much faster way. So here instead of writing x1 by y1 is equal to x2 by y2, I directly wrote x1 by x2 is equal to y1 by y2 and I have substituted. So the end answer will be the same. So 24 red pigments is the answer for this particular question. So coming to the fourth question, here also they have given two physical quantities and here also they are related directly. That means these two physical quantities are directly proportional to each other. So here the first physical quantity which they have given is number of bottles. So here one company is filling 840 bottles in, so here 840 B I will write. B refers to bottles. So 840 bottles is filled in 6 hours. So here second physical quantity is 6 hours. So the first physical quantity is number of bottles. So how much bottles they will fill in 5 hours? So this is the question. So here this particular 6 hours and 5 hours is the y values. 840 and we don't know the second value. So that is actually the x values. So here you can take this as x1 and x2. Here you can take this as y1 and y2. So according to direct proportionality equation, x1 by y1 is equal to x2 by y2. Or we can write this as x1 by x2 is equal to y1 by y2. So when you take x1 by x2 is equal to y1 by y2, so x1 by x2 is equal to y1 by y2. So what is the value of x1? X1 is actually equal to 840 bottles. X2 we don't know. Y1 is 6. Y2 is 5. So we can substitute that. So x1 is actually 840 divided by x2 is actually we don't know. So x2 will keep it as it is. So y1 is 6. Y2 is 5. Now you can cross multiply this. This will be equal to 840 into 5 is equal to 6 into x2. So here you can bring this 6 to LHS. It will become 840 into 5 divided by 6 will be equal to x2. Or you can write this as x2 is equal to 840 into 5 divided by 6. So here you can solve this. This can go with 2. So 2 3s are 6. 2 4s are 8. 2 2s are 4, 0. So 3 1s are 3, 3 1s are 3, 1 is remaining 12, 4s are 12. So 14, 1 0 is there. 140 into 5. So what is 140 into 5? 5 zeros are 0, 5 4s are 20, 2 carry, 5 1s are 5 plus 2 is 700. So x2 is equal to 700 bottles. So in 5 hours this particular company can fill 700 bottles. So coming to the fifth question in this particular exercise, here they have actually enlarged an bacteria under microscope. So when enlargement is done for 50,000 times, so when enlargement was done for 50,000 times, the image of bacteria was 5 centimeter in length. That means when 50,000 times enlargement was done in microscope, bacteria was having an image of 5 centimeter. Now, what will be the actual length of bacteria? So only when it was enlarged, it was looking like a 5 centimeter long bacteria. But what is its actual length? That means you should not enlarge at all. So you should not enlarge means at that particular time it will be 1 time. So 1 time means there is no enlargement at all. So at that time what will be the length? So this will actually give you the exact length of the bacteria. So this is actually the length of bacteria which you should actually calculate. So here this acts as x1, this acts as x2, this acts as y1 and this acts as y2. So here 5 centimeter is there. Here we should actually calculate y2. So x1 by x2 is actually equal to y1 by y2. I have already explained this. So what is x1? x1 is 50,000 divided by x is 1. So here y1 is 5 centimeter divided by y2. Now you can cross multiply this. So this will be equal to y2 into 50,000 is equal to 5 centimeter into 1. So here y2 is equal to 5 centimeter divided by 50,000 will be there. So 5 1s are 5. 5 1s are 5, 4 zeros are there. So 4 zeros you should put here. So you know that when you put 4 zeros, it is actually 10 power 4. So if you refer my previous video where I have explained exponents and powers, so there I have explained whenever you are taking a number to numerator or denominator, the sign of the power changes. So here 10 power 4 is there. When you bring that to numerator, it will become 10 power minus 4. So this is actually equal to 10 power minus 4. Here this is actually 5 centimeter. So here also centimeter will be remaining as it is. So it will be remaining as it is. So 10 power minus 4 centimeter is the length of bacteria. So this is the actual length of bacteria. Coming to the second part in this fifth question, here they have asked when 50,000 times enlargement was happening. So at that time the bacteria was actually 5 centimeter in length. So what will be its length when 20,000 times enlargement is happening? So now we know that this particular 50,000 is x1, this particular 5 centimeter is y1, this particular 20,000 will be x3 and this particular question mark will be y3, because here x2 and y2 I have already taken. Here x2 is 1 time that is when there is no enlargement. And here y2 is actually we have calculated, that is the actual length of bacteria. So now at 20,000 magnification it will become x3, and this particular value which we don't know will be y3. So now x1 divided by y1 will be equal to x3 divided by y3, because these two are directly proportional to each other. So here you can substitute the values for this. Here instead of taking x1 by x3, y1 by y3, I have taken x1 by y1 is equal to x3 by y3. So x1 value is 50,000 and y1 value is 5 centimeter. So which is actually equal to 20,000 times divided by y3 value. Now you can do cross multiplication. It will become 50,000 into y3 is actually equal to 20,000 into 5 centimeter. So now you can bring this 50,000 to RHS. It will become 20,000 into 5 centimeter divided by 50,000. So here 4 zeros get cancelled each other. So here 5 and 5 gets cancelled each other. So 2 will be remaining and this particular centimeter will be remaining. So 2 centimeter is the length of bacteria when it is enlarged 20,000 times. When there is no enlargement at all, at that particular time you will get the actual length of bacteria that we have calculated to be 10 power minus 4 centimeter. So when it was 20,000 times enlarged, at that time the length of bacteria was 2 centimeter. So this 10 power minus 4 centimeter is the answer for first part, and this 2 centimeter is the answer for second part in this particular fifth question. So we are actually discussing a sixth question here. So the length of a model ship, the length of mast of a model ship, mast is the cloth which is actually tied on that particular ship to know the direction of wind and to support the movement of that particular ship. So this is the length of mast in actual ship, and the 9 centimeter is the length of mast in a model ship. So if there is a big ship, actual ship which has mast, that mast is equal to 12 meter. And if you are creating a miniature of that particular ship and you are creating a model of that particular ship has the mast equal to 9 centimeter. Now if the original ship was 28 meter, like if that particular actual ship has 28 meter long mast, then how much the model ship will be having? So that is the question. So this will be x1, this will be x2, this will be y1, and this will be y2. So now let us take x1 by x2, or x1 by y1 is equal to x2 by y2, or you can take it as x1 by x2 is equal to y1 by y2. So what is x1? x1 is 12 meter, x2 is 28 meter. Here meter gets cancelled, is equal to y1 is 9 centimeter, y2 we don't know. So we can cross multiply this. So 12 into y2 is actually equal to 9 centimeter into 28. You can bring this 12 to RHS. It will become y2 is equal to 9 centimeter into 28 divided by 12. So here 3 3s are 9, 3 4s are 12, 4 1s are 4, 4 7s are 28. So 7 into 3 will be 21 centimeter. So the length of the mast of a model ship should be 21 centimeter when the length of mast of a original ship is 28 meter. Coming to the seventh question, here they are actually telling that here 2 kg of sugar contains 9 into 10 power 6 crystals. So here 2 kg of sugar contains 9 into 10 power 6 crystals in it. So now they have asked 2 questions in this particular seventh question. So what if there is 5 kg of sugar, then how much crystals will be there? And when there is 1.2 kg of sugar, how much crystals will be there? So this acts as x1, x2 and x3. This acts as y1, y2 and y3. So we know that x1 by x2 is equal to y1 by y2, or we can take this as x1 by y1 is equal to x2 by y2. So what is x1 and y1? So x1 is 2 kg, y1 is 9 into 10 power 6. So x2 is actually equal to 5 kg and y2 is actually, we don't know, we'll just keep it as y2. Now when you make cross multiplication of this, so this will be equal to y2 into 2 is equal to 5 into 9 into 10 power 6 crystals. So here you can bring this 2 to RHS. It will become 5 into 9 into 10 power 6 divided by 2. So 9 5s are 45. 45 by 2 will be there. So 45 by 2 will be equal to 22.5. So 22.5 into 10 power 6 crystals will be there if there is 5 kg of sugar. Similarly, take x1 by y1 is equal to x3 by y3 and find out y3. That is how much crystals of sugars will be there when 1.2 kg is there. So one problem I have solved, another problem you can solve like this. So 22.25 can also be written as 2.25 into 10 power 7 crystals. Because when you move this particular decimal point to your left side and you move that decimal point after one digit, so you can add power 1 in the place of 10. So here already 10 power 6 is there. So you can add one more power for that 10. So it will become 10 power 7. So either you can write 22.5 into 10 power 6 or 2.25 into 10 power 7. So you can refer powers, exponents and powers chapter for this details of how power works. So here answer for first question is 2.25 into 10 power 7 crystals. Answer for second question you can actually find out. So distance on a particular map is 1 centimeter. So in 8th question, distance on a map is equal to 1 centimeter means, so the original length will be equal to 18 kilometers. So on map, if there is distance of 1 centimeter means originally there is 18 kilometer distance. So now if a particular person is driving 72 kilometer, then how much distance she is covering on that particular map? So here this particular thing will become x1 and this will be x2 and this will be y1 and this will be y2. Now x1 by x2 is actually equal to y1 by y2. So here x1 is actually 1 centimeter, x2 we don't know. Y1 is 18 kilometer, y2 is 72 kilometer. Here kilometer cancels, 18 ones are 18 fours are 72. Now you can cross multiply 4 into 1 centimeter, x2 into 1. So 1 centimeter into 4 will be equal to x2 into 1. So when we do cross multiplication, so x2 will be equal to 4 centimeter because 4 into 1 centimeter will be 4 centimeter. So she is actually covering 4 centimeter on the map when she actually covers 72 kilometers originally. So the answer for this 8th question will be 4 centimeter. Coming to the 9th question, here they have given the length of the pole and the length of that particular pole's shadow, and they are directly proportional to each other. So here when the length of a particular pole is 5 meter and 60 centimeter, at that particular time it was actually casting 3 meter 20 centimeter long shadow on the ground. So now here based on this data they have given two questions, first and second. So in the first question you should actually find out the length of shadow when the length of the pole is equal to 10 meter and 50 centimeter. So here you should find out what is the value of shadow. Coming to the second question, they have given the value of shadow that is actually 5 meter. Now you should find what is the length of this particular pole. So this particular length of poles will be equal to x. So this will be x1, this will be x2 and here this will be x3. Here this will be y1, this will be y2, this will be y3. So here you should find out x3 and you should find out y2. So we know that x1 by y1 is equal to x2 by y2. So what is x1? x1 is 5 meter 60 centimeter. Y1 is 3 meter 20 centimeter. So x2 is 10 meter 50 centimeter. Y2 we don't know. We'll just keep it as it is. So we'll substitute in the place of x1 by y1. X is equal to x2 by y2. So when you substitute, you will get 5 meter 60 centimeter as your x1 value. So y1 is actually 3 meter 20 centimeter is equal to x2 value will be 10 meter 50 centimeter, which divided by y2, which we should actually calculate. So when you cross multiply this, it will be equal to y2 into 5 meter 60 centimeter is equal to 3 meter 20 centimeter into 10 meter 50 centimeter will be there. So now you can bring this 5 meter 60 centimeter to RHS. It will become y2 is equal to 3 meter 20 centimeter into 10 meter 50 centimeter divided by 5 meter into 60 centimeter. So here you should see one is given in meter and one is given in centimeter, total length. Now you should convert that to one single SI unit. So 20 centimeter means, always you should remember 1 centimeter is equal to 0.01 meter, or 1 meter is equal to 100 centimeter. So now 20 centimeter is there means it is actually equal to 0.01 into 20, that is actually equal to 0.2 meter. So here in the place of 20 centimeter you can write 0.2 meter and you should add that particular 3 meter to it, because length is actually equal to 3 meter and 20 centimeter. What do you mean by 3 meter and 20 centimeter? This is actually equal to 3 meter plus 20 centimeter. So this is the total length of the pole. So what is 20 centimeter? 20 centimeter is 0.2 meter. So this will be equal to 3 meter plus 0.2 meter. So this will be equal to 3.2 meter. Similarly here, when you take 10 meter 50 centimeter, so at that time this is actually equal to 10.5 meter, because 50 centimeter is 0.5 meter. So 0.5 plus 10 will be 10.5 meter. So like this you should actually substitute. So here we got that y2 is equal to 3 meter 20 centimeter into 10 meter 50 centimeter whole divided by 5 meter into 5 meter 60 centimeter. So here 3 meter 20 centimeter into 10 meter 50 centimeter divided by 5 meter 60 centimeter is there. Now you can substitute the values. 3 meter 20 centimeter means it is actually 3.2 meter into 10.5 meter. Here 60 centimeter means it is 0.6 meter. So 5 meter plus 0.6 meter will be 5.6 meter. So divided by 5.6 meter. So here it is 10.5 meter. The value which we are getting for y2 is actually 3.2 meter into 10.5 meter divided by 5.6 meter. Here 1 meter gets cancelled. So here you can solve this. So when you actually solve this, meter gets cancelled. 3.2 into 10.5 will be 33.6. So 33.6 divided by 5.6 will be equal to 6 meters. So 6 will be the remaining value. So 6 meter is the answer for first question in this particular 9th question. Similarly, you can take the next value as x3 and y3. You can actually do it as x1 by y1 is equal to x3 by y3, and you can actually easily solve the x3 value, which you should actually find in the second question in this particular 9th question. So one question I have solved, the second question you can actually solve in this particular 9th question. So coming to the 10th question in this particular exercise, there they have given a truck travels 14 kilometer distance in 25 minutes. So how much distance it will actually cover if the speed remains constant? So here you should remember the speed is constant. That means these two are directly proportional to each other. That means 15 kilometer and the time covering. So how much distance is covered by a particular truck? Because you should always remember speed of a truck is actually distance by time. So if speed remains constant means this acts as a proportionality constant k. So here d by t will be constant. So that means speed will be constant throughout the journey. So if that speed is constant means it is directly proportional. That means distance and time is actually directly proportional to each other. So here distance is 14 km in 25 minutes. So in 5 hours how much distance this particular truck will actually cover? So this is actually x1, this is actually x2, this is y1, y2. So x1 by x2 is equal to y1 by y2. When you do that, x1 is 14 km divided by x2 we don't know is equal to y1 is 25 minutes divided by hours is there. Hours you should actually convert to minutes because same SI unit should be there while calculating. So you should always remember 1 hour is actually equal to 60 minutes. Then 5 hour will be equal to 6 5s are 300 minutes. So in the place of 5 hours, I will write 300 minutes. Now you can cross multiply this. It will become 14 kilometer into 300 minutes is actually equal to 25 minutes into x2. So what we got is x2 into 25 minutes is actually equal to 14 kilometer into 300 minutes. So now you can bring this particular 25 minute to RHS. It will be equal to x2 is equal to 14 into 300. Here kilometer is there. Here minute is there. Divided by 25 minute. So here minute gets cancelled. So 5 5s are 25, 5 6s are 30, 0 is there. 5 1s are 5, 5 1s are 5, 2s are 10. So 12 will be remaining. So 14 into 12. So what is 14 into 2? 14 into 2 is 28. 28 plus 14, 140 will be 168. So 168 kilometer is the answer for this particular 10th question in this particular exercise. So this is all there in this particular chapter. This is the part 1 video of direct and inverse proportions, where I have explained just direct proportions in this particular part. The second part of this particular same chapter will be on inverse proportions, and I will solve exercise 11.2 in that particular chapter, in that particular part as well. So like this, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.